Okay, now we're ready. So, okay, so we've got the situation. It says, part A, use the data in the table, so use this, to approximate C prime. Okay? C prime is the rate, it's the instantaneous rate at which C is changing. So because C is the amount of coffee, they're asking you to look somehow right here at time equal 3.5 and figure out how fast is, what's the rate at which the amount of coffee is changing right at that moment. That would be 2.5. Raise your hand if you notice that, please. 3, we're down 5, what the heck. All right. So here we go. That was terrible. Okay. So we're trying to find an instantaneous rate of change. You should have a flashcard that reminds you. You always approximate an instantaneous rate of change by computing an average rate of change. So we're approximating C prime of 3.5, but we're doing it by finding an average rate of change. Average rate of change is common sense. At time 4, there's 12.8 ounces in the cup. At time 3, there's 11.2. So that means over that 1 minute time period, the amount in the cup went up by 1.6 ounces per minute. If it's a rate, it has to be a ratio. So if you have both boxes here, because units were required on this one, you get 2 points. Again, don't be lenient with yourself. If you have both boxes, you get 2 points. If you want to approximate an instantaneous rate of change, do that by calculating an average rate of change.
So it's like the straight line.
Huh? Yeah, so instantaneous rate of change means tangent slope. Average rate of change means secant slope. So you're approximating a tangent slope via a secant slope. Perfect. Anybody else? Please.
So if I have both of those boxes provided instead of the approximate sign, it would be sign?
I think they'll forgive you for that one. Would be better to use approximation, but I think you're okay. Jake?
So I have the 12.8 minus 1.0 over 4 minus 3, but I don't have the C prime of 3.5 because it's approximate.
I think you'd be okay on that one. Better to always indicate what you're finding, but I think they'll forgive you too. Anybody else? Awesome. Okay, next one. Part B. Is there a time from 2 to 4 where the instantaneous rate of change will be 2? All we have is this table. It goes back to the same idea again. You can approximate an instantaneous rate of change with a average rate of change. And what they're hoping you'll kind of pull out of thin air, to be honest, a little bit, they're hoping this will prompt you to remember the mean value theorem. Please do not make the mean value theorem a high priority. For example, on the entire AP test, I would say out of 108 points, you're at most going to earn about 3 points using the mean value theorem, at most. If you understand the fundamental theorem, you're going to earn about 30 points. Okay, so it's much lower priority. But anyway, what you have to do is what I did here. You have to find the average rate of change between 2 and 4. You notice that that average rate of change does turn out to be 2. So because the average rate of change from 2 to 4 is 2, and because the function c is differentiable, that means that c is also continuous. Therefore, therefore the mean value theorem applies, which means that there will be some point between 2 and 4 where the instantaneous rate of change will be equal to 2. This is worth 2 points, but I don't think you should stress much about it. There's no way to actually find it. The C prime is approximate would be this. They were. You are remembering one thing that's good though. You're remembering that whole idea, which to me is more important. The idea that you can always approximate an instantaneous rate here, an average rate. They won't do it.
CO2 is what we're gonna so between 2 and 4, CO2 prime and T must be
They won't do it.
Then you should ask me.
Yeah, hey, should be ready. Listen, again, please. There's hardly anything that I would consider lower priority than the mean value theorem. It's not heavily tested. It's often difficult to identify when they want you to use it. So don't make it a high priority, but what they're expecting you to do here is, first of all, find the secant slope between 2 and 4. Once you notice that that secant slope is indeed equal to 2, you have to justify the use of the mean value theorem. So you have to say something about C is differentiable, that says right here. So C is therefore continuous. And the mean value theorem will then guarantee that between t equal 2 and t equal 4, there's some t value where the instantaneous rate of change of C will be 2. That's, you almost have to write word for word what I've written to get the point. Thank you.
So I think what I have is wrong. I'm just curious why
Sure.
it's wrong. So what I did is I found, or I approximated C prime of 4 by doing 5 and 3, and then I approximated C prime of 2, 3, and 1. And then I said there must be at least one value that's 2 because of the intermediate value theorem, because 1 is above 2, 1 is above 2. And so
Interesting.
I did that too.
The reason why the intermediate value theorem doesn't technically apply is because you're like doing a double approximate. You're approximating, you're trying to use the intermediate value theorem as it would apply to the function C prime. Because you're trying to justify why C prime has to be 2. But you have no way of actually calculating C prime. You're approximating C prime using average rates of change. So it's a flawed proof. They won't allow it. So the logic is very good though. Like honestly, the way you're
Was all the way
thinking.
wrong?
Yeah, you won't get any points. But the way you are thinking about it is very, very good. So that's fine. But it's just not matching what they want. Anybody else? Well, next one. It says use a midpoint sum with 3 subintervals of equal length. So keywords, midpoint, hey, please, slow down. Somebody last period lost both points on this one because they just read too quickly. They read trapezoidal. Like just, serious. Like, slow down. Midpoint sum, 3 subintervals, equal length. So I come up here and go, okay, so there's 1 subinterval, second, third. Okay, good. To approximate this integral, box that so you know exactly what you're finding. There's a period, so I need to go do that. So I did. Go down the integral. Integral's approximately equal to. You need to have exactly what I have in green. If you do, you get 2 points. What's that, Laura? Okay, if you forget this, I think they will forgive you. But keep trying to get, like, my advice is the better you can match what they expect, the better chance you have of not losing any points. I honestly think if you wrote equal or you forgot the integral, they'll still give it to you. You cannot forget the 1/6. Okay? So you got it? You don't have to, but I think it's better. Like, I think it's safer to write the integral, say approximately, so the grader knows exactly what you're doing. Anyone else? Awesome. That's 2 points in green. Then it says, using correct units, explain the meaning of this expression in the context of the problem. Okay, to get those points, you really have to have a copy of what you see here. If you don't have exactly what you see here, you probably didn't get it. So if you're a little if you're borderline, just raise your hand, read it to me, I'll tell you whether you got it or not.
I just said the interval, once is the interval, so this is means the average amount of ounces between T equals 0 and equals 6 minutes.
That's okay. Yeah, that's very good. No, that was very good. You hit all the key points. You didn't talk about a rate because it isn't. You said it was the average amount, and you got the units, average amount of ounces. You didn't say coffee, but I don't forgive you for that one. And then you said the time frame, you said minutes. It's very good. Thank you.
I said water instead of coffee. Water is dripping through the coffee maker.
I think they'll forgive you.
What is water? Did you say that it increased?
No, you can't say that. Here's why. Hey, 2 for Laura. Good question. The reason you can't use the word increase is because you're looking at a time period, 6 minutes, and you're finding the average for the time period. So there's no way to associate the word increase with an average. Does that make sense? Now, if you were finding an average for one time period versus an average for another, we could use the word increase or decrease, but that's why they won't.
Why do you not need units in the actual equation?
Up here,
Yeah.
I honestly think it would be best to include them, but because in the scoring guide they didn't specifically require it, you luck out. Good question. No problems for that.
So you have to have units in the bottom.
Yes, because they did specifically mention it. And what I've been trying to say, and I struggle myself, is that if you'll just always put units in your final answer, then you never risk forgetting it. But they would forgive you on that one. No problems with Dawson and also Dave. Yeah. Okay, cool. Part D. The amount of coffee in the cup in ounces. So I read that slower. The amount. Yeah, read slow. Coffee in the cup, ounces. The amount of coffee in ounces is modeled by this. Make sure you box that. And this is an amount. Okay, using this model, so I'm supposed to use this, find the rate. So now I'm looking for a rate. So I'm trying to find a rate at which the amount of coffee is changing when t equals 5. So if I know that this is the amount of coffee, the rate at which the amount changes is simply a derivative. No calculator allowed, so I go to work. So b prime of t is going to equal, derivative of 16 is 0. 16 is a multiplying constant. Derivative of e to some exponent is e to that same exponent, multiplied by the derivative of that exponent. Do you have a question to that? That's 1 point. I'm supposed to find b prime at time equal 5, so all I have to do is plug in. I don't have to do any simplification. So I won't, otherwise I risk a mistake.
What?
Oh, please, Bob.
What if you multiply -0.4 times it?
No problems with that. I mean, there's nothing wrong with doing that. So read what you have.
3.65. I don't know how I got that. I divided.
Yeah, hence
I
don't
did
do it.
multiply.
Yeah, hey, 2 for Laura.
Like,
Everybody,
what the?
listen, listen, listen. It really is a superb example of why you don't want to, because you lost the point by doing this.
Yeah.
So just stop.
Okay, so I didn't stop either, but did it equal 6.4?
Yes.
Yes.
Positive or negative?
Positive.
Yes.
Yay.
So you did get that right, so you're okay. That's worth the point. Anybody else? Please, Mary. No one talk, I can't hear.
I was really confused at first because it's like the amount of coffee in the cup and ounces, which I thought was 60. So I put B and T equals 60.
Right, you just read a little bit too fast.
Okay.
The amount of coffee in the cup, because we're talking about an amount, in ounces, is modeled by this, period. So that part you did understand correctly. The B of T, C of T is really, so here's the difference. C of T is what they measure as the amount. B of T is a model, being a mathematician creates an equation that basically mimics this. So that's why you accurately thought that B of T and C of T are the same thing. They roughly are. You okay with that? I bothered you then.
Yeah, but no, not your answer, just the way that they were.
Yeah.
Because,
Come talk to me, we can get that to click better. Just talk to me for a minute.
so they are different though?
Okay, let me say it again, everybody, hey, listen, everybody, eyes here, everybody, come on. Okay, what they're doing here is pretty common, happens a lot. So if you'll get this to click, and you'll just keep talking with me until it clicks, it will help you a lot. C is definitely the amount of coffee in the cup. It's the measured amount, it's the observed amount. Meaning, time 0 there isn't any. Time 1 I look at the cup and I can see that there are this many ounces. I wait another minute, I see that there are this many ounces. So it's the measured amount, you good? Okay, a model means, can you figure out mathematically how to create an equation that pretty much matches this? It won't match it exactly because it's a model, but it's close. Like if I plug in time equal 6 into this equation, I probably won't get exactly 14.5, but it will be close. That's what they mean by B of T is the model for the amount of coffee.
Okay.
Did that click?
Yeah.
Okay. Using the model, find the rate. So we're not trying to find the amount, we're trying to find the rate.
Okay.
So to find the rate from the model, since the model models the amount of coffee, you have to take the drift. Does that help?
Yeah. Like,
Two more comments.
So that equation is basically like, that's the line goes.
It's a curve, it's not a line, but yeah. Anybody else? Perfect. So plug it in, so just write this down. Excuse me. I would not do any simplification at all. Otherwise you risk making a mistake. So right here,
So you can just leave it like that.
just leave it. Sweet is the right word. Blue box is 1 point, purple box is 1 point. Please.
So because they don't have a calculator, they're not expecting the rate.
Even if you had it calculated, the rules of the test say you don't have to go further. Mary?
sorry, so to find B prime 5, I approximated C prime 5, and they come out to be pretty close. Well, they would probably still count wrong. Right?
Yeah, well, they'll count it wrong. Here's why, Mary. What you did is you used C to approximate B prime of 5.
Yeah.
Their instructions said to use the model. That's all. Does that make sense? That was fine.
I didn't write B prime of 5 equals for the, would I not?
I think they'll forgive you, but I would develop that habit, just say for everyone. Because I always have to say, I think. Yeah, it just makes me a little nervous. Anybody else? It's really, like, this is the 3rd practice test we've done. It's why I feel like it's so important to do several practice tests in calculus. I don't know how other AP classes are, but you do have to pick up on the feel of the test a little bit, like what you have to write. So. Okay, next one. So that was 3, right? We're done? Number 4?